Hello everyone. In this video we'll be covering our fifth section of our data and statistics unit, which goes over two-way tables. So we're going to go ahead and jump right in with some examples. We have this two-way table here, which is actually from my current 7th hour class. This is data that we collected in those surveys that I had you guys fill out at the beginning of this semester. So we're going to start with question 1. What percent of the class, my 7th hour class, is freshmen? So if we look at our two-way table, you'll notice that we have some categories on the top and on the side. So on the side I have male and female, and then on the top I have freshman, sophomore, junior, senior, and both sides have a total column. So this total is the total of all the freshmen. This total is the total of all the sophomores. This total is the total of all the juniors. This total is all the seniors. And then on the side, you're counting your total horizontally. So the total of all males is over here. The total of all females is right here. And then this last box where you have the total of both the top and the side, we actually have to fill in there, and it should be equal. So if we add 16 plus 4, that gives me 20. And if I add these things, it should also be equal to 20. So I have 9 plus 10, which is 19, plus 5 is 24, which is not 20. Did I miss something when we were counting before? I might have missed something. Let's see. This is definitely 4. 9 plus 7 is 16, plus 4 is 20. Oh, this should be 20 up here. So there's a mistake, so let's fix that right now. So that's 20, which means that our total is actually 24. Okay, now it makes sense. And if you are checking your work and you find an error like that, then there's something that you need to look at again in your data. All right, so question 1, what percent of our class are freshmen? So we are going to take our number of freshmen, which is 9, and we are taking that out of the total number of students in our class, which is actually what this number over here is. This is the total number of students in the class. So I have 9 divided by 24, and that will give me my percentage, which is 9 divided by 24. That is 0.375, which means that we have 37.5% of my 7th hour is freshmen. And you should be writing this all as a sentence for sake of time in this video. I'm going to be leaving everything as a number, but you should be writing your answers as complete sentences. Number 2, what percent of our class is female? So we need our total female count, which is 4. And we again are looking out of the total number of students in that class, which is 24. 4 divided by 24 gives me 0.16 repeating. So 0.1, and that'd be 6 repeating really. So it looks like that, which means that it's about 17%. So about 17% of my 7th hour is female. Number 3, how many students in our class are sophomore and male? Okay, so this is looking at the column of sophomores, but you only want the male sophomores. You don't want the female sophomores. So we're not looking at our total. We're not including females. We're just looking at this number here, which is 7. So 7 out of my total 24 students are male and sophomores. And as we calculate that, 7 divided by 24 is equal to 0.29, about. So we are at about 29% of the class is both sophomore and male.
We're going to interrupt here for a minute. I realized as I was editing my video that I accidentally misread a couple of the questions, so we're going to redo them real quick. So number 4 here says how many students in our class are sophomore or female. When we say sophomore or female, that implies that we have to look at the total number of sophomores and the total number of females. But you have to be careful because you can't double count them. So you can't include this 3 that's in both the sophomore column and the female row. So you're going to pick one of the totals. I'm just going to use this 10 from our total number of sophomores. And we're also going to count how many females are not included in this one column. So I have 10 plus 1 from the female that's a junior, so that really means that I'm looking at 11. And we'll write that down here as 10 plus 1 out of the total number of students in our class, which is 24. Or in other words, we're really looking at 11 divided by 24, which is about equal to 0.46. So we have about 46% of our class that is sophomore or female.
Then number 5, it says what percent of the females are sophomores. So this time, we're not looking out of our total class, we're looking out of our total number of females. So if we look at our females, there's 4 total females, and we want to know what percent of those females are sophomore. So if we come up here and look at our females in the sophomore category, there's 3 of them. So I have 3/4 of my 7th hour class of the females in my 7th hour class are sophomores, which is 75 or 0.75. So that is 75% of the females in my 7th hour are sophomores. All right, so there's one example. We missed a question there. Number 6, it says what percent of the sophomores are female? So that's actually doing the opposite of what we just did, where we found the total number of females and then we took our number of sophomores out of it. This time, we're going out of the total number of sophomores, which up here is 10. And we want to know how many of those sophomores are female. So that is 3 because it's in the sophomore column and it's in the female row. So we have 3 out of our 10 sophomores are female, which is 0.3 or 30%. All right, now we've completed an example where you have a full complete table except for our little mistake in our total. But sometimes your table will be kind of empty and it'll look kind of like this. We can figure out what goes in the table using the information that we do have. So for example, we know that there's going to be a total of 50 in both this column and this column. And I know that to find my total of males, I need to add these 2 numbers together. So I have 16 plus 7, which is equal to 23. And I have 16 plus 8, which is equal to 24. And now I need to subtract 24 from 50. 50 minus 24 is equal to 26. And 50 minus 23 is equal to 27. So I should have a number to go here that will satisfy both this addition problem, 7 plus something is equal to 26, and it should also satisfy this addition problem, something plus 8 is equal to 27. So let's think about that. 26 minus 7 is equal to 19. 19 plus 8 is equal to 27, so that checks out. So that was question 7 here. Complete the table. So we did that. Now it says what percent of the students wear sandals in this class? So if we are looking at students who wear sandals, that's our total of 26. And we're looking out of all the students in the class, which there's 50 of them. So I have 26 out of 50. To calculate this percentage, because 50 is our denominator, you have 2 options. You can either multiply both the top and the bottom by 2, and it will give you a nice easy percentage out of 100, or you can just divide like we were doing before, 26 divided by 50. So I'm going to multiply both of these by 2 just so you can see that in this example. So 26 times 2 is equal to 52 out of 100, which means that our percentage is 52%. So 52% of the class wears sandals. And again, that should be a complete sentence. Number 9, what percent of the students are female and wear sandals? So we are in our sandals column, and we are looking for both female and sandals. So I can only include the row that is females, which is 19. So I have 19 students who are female and wear sandals, and we're looking out of the total number of students for our percentage. So we're still out of 50. And we'll do division on this one. 19 divided by 50 is 0.38. So that means that we have 38% of the students in this class that wear sandals and are female.
All right, we're going to interrupt here again to look at questions 10 through 12. So number 10 says, what percent of the students are female or wear sandals? So on this question, we need to make sure that we're accounting for all of the students who wear sandals and all of the students who are female, but we can't double count them because some students are female and wear sandals. So I'm going to start by looking at the 27 total females, and to that I'm going to add the 7 male students who wear sandals. And we're going to take that out of our total number of students. So I have 27 plus 7 out of 50, which is the same as 34 divided by 50. And 34 divided by 50 is equal to 0.68, which is 68%. So 68% of the students in our class are female or wear sandals. Number 11 says, what percent of males wear sandals in the class? So for this question, it says what percent of males. So the total number of students is not what we're looking for because we're only concerned with the male students. So we have to look at our total number of male students, which is right here. That's 23. So I have some number of male students that wear sandals out of the 23 male students total. If we look at our chart up here, in the male row, in the sandal column, we have 7 students. So we have 7 out of 23. 7 divided by 23 is about equal to 0.30. So about 0.3, which is 30%. So 30% of males wear sandals in our class. And number 12, it says, does there appear to be an association between gender and sandals? So if we're looking at this data here, it does show that more females tend to wear sandals than males do for our class. So we can say it appears that female students tend to wear sandals more than male students. That being said, we also have to understand that our data is specifically looking at students in one class, so we can't use this data or this tendency for the generalization that there's an association between gender and sandals of all people as a whole. So we also have to add, however, there is not enough information, or there is not enough data to make the generalization that there is an association between gender and sandals.
That is where we are going to stop for today. This whole section is on two-way tables. I do remember in the past several of my students would get a little confused when they're trying to read the table and knowing which categories to look at, if it's an and or an or question. So we'll be spending a little extra time reviewing in class with those things. If this is something that you are having a hard time with, I highly recommend that you are emailing and asking for help when you get to those questions. We'll pick back up with section 6, which will cover scatter plots and how we describe them.